What if the next world speed record doesn't come from Silicon Valley, or Germany, or Italy, but from a workshop far from the traditional centers of automotive power? Imagine a machine engineered not just to compete with the fastest cars on Earth, but to rewrite the rules of speed itself. This is the story of the Speed King, Maxwell Chikumbutso's groundbreaking hypercar. A vehicle rumored to challenge conventions, to question physics, to blur the line between combustion-era engineering and a new technological frontier. And if even half of the claims surrounding it are true, the hypercar industry may never be the same again. Because speed is no longer just about horsepower. It's about intelligence. For over a century, the world's fastest cars have followed a familiar formula: larger engines, advanced aerodynamics, lighter materials, and relentless wind tunnel testing. From the roaring beasts of early motorsport to today's multi-million-dollar hypercars, the race has always been about pushing limits by refining what already exists. But what happens when someone decides not to refine the formula, but to replace it? Maxwell Chikumbutso has long been associated with unconventional engineering ideas, concepts that challenge mainstream assumptions about propulsion, energy systems, and mechanical design. Whether praised as visionary or questioned by skeptics, one thing remains undeniable: he does not think small. And this hypercar represents the boldest extension of that mindset. Unlike traditional hypercars that rely on massive combustion engines or even hybrid electric systems, this machine is presented as something fundamentally different: a performance platform built around alternative energy architecture and proprietary electronic control systems. At its core, the car is said to combine ultra-lightweight composite materials with a high-output electric propulsion system designed for extreme torque delivery, instant acceleration, zero lag, controlled power curves tuned not only for speed, but for stability at record-breaking velocities. Picture the silhouette: low, aggressive stance, sculpted aerodynamic channels carved into the body like veins on a living organism, active aero elements adjusting in real time, responding to speed, wind resistance, and cornering force. This isn't just design for aesthetics. It's design for dominance. Every millimeter of the exterior serves a purpose, from air intake geometry to underbody airflow management. High-speed stability becomes less about brute force and more about intelligent airflow orchestration. And then there's acceleration. In the world of hypercars, 0 to 60 miles per hour times have become almost absurd. 2 seconds. Sometimes less. But acceleration is only the beginning of the speed equation. Sustained velocity is where legends are made. Top speed records demand not just power, but thermal efficiency, structural integrity, and aerodynamic harmony. At extreme speeds, even microscopic design flaws become catastrophic, which raises the critical question: could this hypercar truly challenge established giants? Names like Bugatti, Koenigsegg, and Rimac dominate the upper echelon of performance engineering. They invest billions into research, wind tunnels, advanced materials, and track validation. To compete in that arena requires more than ambition. It requires proof. Yet what makes this project fascinating isn't just whether it can break a record, it's the philosophy behind it. Because speed, in this context, is symbolic. It represents independence from traditional automotive power structures. It suggests that innovation doesn't require legacy factories or century-old brand prestige. It suggests that the next revolution in performance engineering might emerge from unexpected places. And if this hypercar succeeds, even partially, it could inspire a wave of decentralized innovation in the high-performance sector. Imagine a future where hypercar dominance isn't monopolized by a handful of European brands. Imagine record attempts broadcast live from new continents. Imagine alternative propulsion systems redefining what performance even means. But beyond the speculation, there's the machine itself. Inside the cockpit, minimalism meets futurism. A driver-focused layout dominated by digital instrumentation. Real-time telemetry streaming performance metrics. Adaptive driving modes that shift the vehicle's behavior from controlled precision to unrestrained acceleration. No unnecessary luxury. No distraction. Just speed. And as the vehicle lines up on an empty stretch of test track, air dense, tension rising, there is a moment of silence before the launch. No roaring combustion soundtrack, just a sharp surge of electric force. The car lunges forward, gripping asphalt with calculated aggression. Within seconds, it becomes a blur against the horizon. And this is where the narrative deepens. Because breaking a speed record is not just about engineering. It's about validation. If verified independently, such a milestone would echo across the automotive world. Investors would take notice. Engineers would analyze. Competitors would respond. But if the claims remain unproven, the car becomes something else entirely. A symbol of ambition. A spark for debate. A challenge to the status quo. And sometimes, challenging the status quo is the first step toward genuine progress. As wind resistance intensifies and digital readouts climb, one truth becomes clear. The future of speed will not belong solely to those with the loudest engines. It will belong to those bold enough to rethink what a hypercar can be. And whether this machine ultimately claims a verified world record or not, it has already done something significant. It has forced the conversation, forced the industry to consider that innovation can emerge from outside traditional power circles. And as engineers refine the prototype, as testing continues, as speculation grows, one question remains unanswered. How fast is fast enough? When the real race is about redefining possibility, the track stretches endlessly ahead. The track stretches endlessly ahead. And the story of this hypercar is still unfolding. Because beyond the spectacle of acceleration and aerodynamic theory lies something even more compelling, the engineering philosophy driving it forward. Speed, at its highest level, becomes a battle against invisible forces. Air density, friction, heat expansion, microvibrations in carbon structures at extreme rotational forces. At 300 miles per hour, physics stops being theoretical, it becomes unforgiving. So, how does a new contender prepare for that battlefield? The answer isn't just raw power. It's systems integration. Modern hypercars are no longer mechanical marvels alone. They are rolling supercomputers, orchestrating torque distribution, traction control, regenerative systems, and aerodynamics in real time. Every millisecond, algorithms adjust parameters that no human driver could consciously manage. If this machine is to stand among the elite, its electronic brain must be as advanced as its propulsion system. Imagine a central control architecture constantly analyzing wheel-slip ratios, surface temperature, atmospheric drag coefficients, and structural stress data, recalibrating power delivery dozens of times per second. Not reacting, predicting. Because at record-breaking velocity, reaction is already too late. And then there's energy efficiency. In traditional hypercars, fuel consumption is almost irrelevant, performance comes first. But in an alternative propulsion platform, energy management becomes central to sustained speed. Delivering maximum output without thermal overload requires advanced cooling pathways, optimized battery chemistry or power generation modules, and intelligent discharge curves. If those systems hold under pressure, something extraordinary becomes possible. Extended high-speed performance without catastrophic degradation. That's the true test. Not a single explosive sprint, but controlled dominance. Now consider the global implications. If an unconventional hypercar platform proves capable of competing with established giants, it sends a message far beyond the racetrack. It challenges assumptions about who can innovate at the highest level. It questions whether access to billion-dollar facilities is truly mandatory for breakthrough engineering. And perhaps most importantly, it inspires. Because young engineers watching from emerging markets may begin to believe that world-class performance design is not geographically restricted. Innovation becomes democratized. The hypercar transforms from a luxury trophy into a technological statement. But skepticism will remain, as it should. In the world of extreme performance, verification is everything. Independent testing, certified timing systems, peer-reviewed engineering validation. Without these, even the boldest claim, remains speculative. And that tension between ambition and proof is what makes this story so powerful. Because every revolution begins with doubt. When the first electric supercars appeared, critics dismissed them as impractical. When hybrid hypercars entered the market, purists resisted. Yet today, electrification dominates the cutting edge of performance. Paradigm shifts rarely announce themselves politely. They disrupt. They provoke. They demand attention. And perhaps this hypercar is not just chasing a speed record. Perhaps it is attempting to spark a paradigm shift. A redefinition of how performance vehicles are engineered. A reconsideration of what power truly means in the modern era. As engineers refine software parameters, test structural tolerances, and push prototypes closer to their theoretical maximum, one thing becomes increasingly clear. The ultimate battle is not against rival brands. It is against limitation itself. Against the long-standing belief that speed must follow a specific blueprint. Against the idea that only legacy manufacturers can shape the future of extreme performance. And if the machine succeeds, even partially, it will not merely enter the record books. It will enter the conversation. A catalyst for new thinking. A reminder that innovation thrives at the edges of convention. Somewhere in a silent test facility or on an isolated runway, another run is being prepared. Sensors calibrated. Systems synchronized. Data loggers primed to capture every fraction of a second. The driver steadies their grip. The countdown begins. And once again, the horizon becomes the only limit. It's about how far an idea can travel. Because ideas move faster than machines. A verified speed record can dominate headlines for weeks. But a disruptive concept, one that challenges the foundations of performance engineering, can influence decades. As development continues, engineers face a critical crossroads. Do they aim for spectacle or sustainability? Because building a car capable of extreme top speed is one challenge. Building one that can do it repeatedly, reliably, and safely, that is something else entirely. Every high-speed run introduces microscopic stress fractures. Every thermal spike tests material limits. Every acceleration cycle pushes electronic systems toward thresholds that were once considered impossible. And this is where true innovation reveals itself. Not in the first dramatic test run, but in the 1,000th recalibration. In the quiet adjustments to airflow mapping. In the incremental firmware updates refining torque curves. In the relentless data analysis sessions that stretch deep into the night. Speed, at this level, becomes patience. Because while the world watches for a headline, engineers obsess over decimals. A 0.01 reduction in drag coefficient. A 0.02 improvement in power efficiency. A fractional improvement in structural rigidity at 280 miles per hour. Those decimals decide history. And as simulations grow more complex, as computational modeling refines predictions, the hypercar evolves beyond a prototype. It becomes a living system. Adaptive. Learning. Optimizing. Imagine AI-assisted performance mapping that studies each run and modifies the next attempt autonomously. A machine that doesn't just respond to driver input, but collaborates with it. Human instinct fused with machine precision. This is where speed becomes something philosophical. Because when artificial intelligence begins influencing vehicle behavior at extreme velocity, we enter a new era of control dynamics. The driver is no longer wrestling with physics alone. They are negotiating with it. And if this architecture matures, it may not stop at hypercars. The same propulsion efficiency breakthroughs could influence commercial transport. The same lightweight composite research could redefine aviation. The same intelligent energy systems could ripple into broader mobility solutions. That's the hidden layer of this story. The hypercar may be the symbol, but the technology is the true prize. Yet every bold vision faces resistance. Traditionalists will question feasibility. Industry veterans will demand certified data. Competitors will quietly study any revealed specifications. And perhaps that pressure is necessary. Because in elite engineering circles, scrutiny is a crucible. It either exposes weakness or forges resilience. If the vehicle withstands that scrutiny, if independent validation confirms extraordinary performance, then the narrative transforms overnight. No longer a controversial experiment, but a milestone. And imagine the moment that confirmation arrives. Global automotive media ignites. Forums erupt in analysis. Engineers dissect performance charts frame by frame. Investors calculate opportunity. Suddenly, the conversation shifts from "is it possible?" to "what comes next?" Because once a boundary is broken, it never fully returns. And perhaps the next iteration pushes further. Higher top speed targets. Improved energy density. Enhanced aerodynamic morphing panels that reshape mid-run. Advanced cooling systems capable of sustaining peak output longer than ever before. Each generation becomes less about catching up and more about redefining the standard. But even if the ultimate record remains elusive, something irreversible has already occurred. A precedent has been set. That innovation can emerge outside traditional power centers. That unconventional thinkers can challenge established hierarchies. That speed is no longer owned by legacy alone. And somewhere in a quiet workshop illuminated by diagnostic screens and carbon fiber molds, the next prototype is already taking shape. Lighter, smarter, faster. Because the pursuit of ultimate velocity never truly ends. It evolves. And as long as there are engineers willing to question limits, as long as there are dreamers who see speed not as a number, but as a frontier, this story will continue accelerating. The horizon remains distant. The data keeps flowing. The machine keeps refining. Because the closer you move toward the edge of possibility, the more that edge begins to move. Wind tunnel sessions grow more aggressive. Simulations begin modeling conditions beyond standard atmospheric assumptions, crosswinds at extreme yaw angles, microturbulence over uneven terrain, thermal distortion at sustained maximum load. Engineers no longer ask, "Can it reach the target speed?" They ask, "What happens after it does?" Because at the outer limits of velocity, control becomes more valuable than raw output. A hypercar capable of extraordinary speed but lacking composure is not revolutionary. It's reckless. And this machine, if it truly intends to redefine performance, must demonstrate mastery. Mastery of airflow. Mastery of balance. Mastery of power delivery so precise that acceleration feels less like force and more like inevitability. Picture a closed test runway at dawn. Air colder, denser, more predictable. Telemetry arrays line the perimeter. High-speed cameras calibrated. Independent observers ready to verify. Inside the cockpit, biometric sensors monitor the driver's heart rate and neural response. Not because it's dramatic, but because at extreme velocity, human focus becomes a measurable variable. The system synchronizes. Propulsion modules hum beneath layered composite shielding. Active suspension lowers by millimeters. Aerodynamic surfaces tilt into low-drag configuration.
Countdown. 3, 2, 1.
The launch isn't violent. It's surgical. Torque surges through all wheels in a perfectly modulated wave. No tire scream. No chaotic spin. Just controlled transfer of energy from system to surface. The horizon begins to compress. 100 miles per hour. Past the point where most vehicles begin to tremble, this one grows quieter, more stable, as if it was engineered specifically for this altitude of speed. Because perhaps it was. Digital readouts climb with unnerving consistency. There's a moment, brief, almost imperceptible, where velocity crosses into territory few machines have ever touched. And, in that moment, something shifts. Not just in the car. In perception. Because whether or not the final number sets a certified record, it proves something critical. The architecture works. The theory holds. The machine is not a fantasy. It is functional. And functionality is the foundation of revolution. Back in development labs, data from the run is dissected relentlessly. Micro-adjustments are identified. Energy curves are analyzed. Aerodynamic anomalies at peak velocity are mapped in 3 dimensions. No celebration, only refinement, because true innovators are rarely satisfied with almost. They pursue iteration, and iteration is where legends are built. The next version may introduce advanced phase change cooling materials, dissipating heat faster than conventional systems. It may integrate predictive terrain scanning that adjusts suspension before irregularities are encountered. It may implement adaptive body panels that flex subtly to reduce drag at hypervelocity. Each layer of evolution tightens the gap between ambition and dominance. But beyond engineering, there is legacy. If this hypercar ultimately secures verified recognition among the fastest machines on Earth, it will stand as a case study, not just in speed, but in disruption. Business schools will analyze the strategy. Engineering institutions will debate the methodologies. Young innovators will cite it as proof that bold thinking can penetrate even the most exclusive arenas. And if it falls short, the impact remains, because it will have forced the industry to respond, forced established giants to defend their benchmarks, forced conversations about alternative propulsion and decentralized innovation. Speed, after all, is only one metric. Influence is another. And influence spreads further than asphalt. As twilight settles over the track and the machine cools from its latest run, the silence carries weight. This is not the end of a project. It is the midpoint of a movement. Blueprints are already evolving. Software updates are already compiling. Simulations are already projecting higher thresholds. Because once you build a machine capable of challenging the world's fastest, you don't slow down. You accelerate. And somewhere in the distance, beyond today's records, beyond current expectations, another barrier waits quietly. Unbroken. Unbroken.
For now.
But barriers have a strange history. They appear permanent, until someone reaches them with the right combination of courage and calculation. Back inside the lab, walls are covered with performance graphs, torque curves layered over thermal maps, aerodynamic flow simulations frozen mid-vortex. Every frame of data from the last run replayed in ultra-slow motion. Because when you operate at the frontier of speed, hindsight becomes your greatest ally. Engineers pause at one particular data spike, a subtle instability at peak velocity. Not visible to the naked eye. Not felt dramatically by the driver. But detectable in the telemetry. A slight oscillation. A whisper of resistance. And that whisper becomes the next obsession. New carbon weave patterns are tested for enhanced torsional rigidity. Micro-adjustments to suspension geometry are modeled digitally before a single bolt is turned physically. Battery discharge algorithms are rewritten to smooth output during sustained top-end velocity. Nothing radical. Everything precise. Because greatness at this level is built from invisible corrections. Meanwhile, the outside world grows louder. Speculation intensifies. Supporters call it the dawn of a new performance era. Skeptics demand transparent third-party verification. Industry insiders watch quietly, not dismissing, not endorsing, but analyzing. And perhaps that scrutiny is the ultimate validation. No one scrutinizes irrelevance. But this machine has captured attention. Not because it claims to be fast, but because it dares to challenge who gets to be fastest. In private test environments, simulations now extend beyond raw speed targets. They explore endurance runs, sustained high-velocity cycles repeated back-to-back. They test system resilience under imperfect conditions, variable temperatures, slight crosswinds, marginally uneven surfaces. Because a true speed king doesn't just rule one perfect moment. It dominates under pressure. Another prototype emerges, lighter by kilograms, smarter by terabytes. Embedded neural networks refine energy distribution dynamically. Structural components are 3D, printed with lattice geometries optimized at microscopic levels. Every generation becomes less experimental and more inevitable. And then comes the strategic decision. Not whether the car can go faster, but when to reveal it. Because in the world of elite performance engineering, timing is leverage. A public record attempt could redefine narratives overnight. A controlled release of verified data could shift investor landscapes. A global live stream could transform a technical milestone into cultural spectacle. Yet the team waits, because they understand something profound. When you aim to change history, patience becomes power. Somewhere beyond the next test horizon lies a number, a figure that, if reached and verified, would echo across decades of automotive legacy. But even before that number appears, a subtler transformation is already happening. Young engineers in distant workshops begin experimenting with unconventional propulsion. Startups revisit assumptions about aerodynamics. Designers rethink what a hypercar silhouette should represent. The ripple effect has begun. And that ripple may ultimately matter more than the record itself. Because records are broken, but paradigms endure. As the sun rises once more over an empty stretch of asphalt, the hypercar rests in silence. Its body reflects the sky like liquid metal. Its systems dormant, yet ready. There is no applause here. No cameras. Just potential. And potential is the most dangerous force in innovation. Because, once unlocked, it demands to be tested again. The engineers step back. Final diagnostics complete. All systems calibrated beyond previous thresholds. The driver closes the canopy.
A breath.
A pause. And then, acceleration surges once more toward the horizon, toward the unseen line where ambition meets reality. The barrier still stands. But it feels closer now. Acceleration surges once more toward the horizon, toward the unseen line where ambition meets reality. This time, there is no hesitation, no doubt, only convergence. Machine and driver synchronized, software and hardware operating as a single consciousness. Physics no longer an obstacle, but a partner. The numbers climb with unwavering stability. Data streams in flawless symmetry. Thermal levels remain controlled. Aerodynamic surfaces hold perfect alignment against the crushing resistance of air at extreme velocity. And then, it happens. A new threshold is crossed. Not just in miles per hour, but in meaning. Because at that instant, it's no longer about whether this hypercar belongs in the conversation. It defines it. The run concludes with calculated deceleration, controlled, disciplined, precise. No drama. No chaos. Just mastery from launch to finish. Back in the control room, silence dominates. Then confirmation. Independent systems verify the figures. Telemetry aligns. External measurement validates performance. A barrier that once seemed immovable now belongs to history. But here's the truth. The record is not the climax. It's the consequence. The real victory happened long before this moment. In the relentless testing, the refusal to accept limitations, the decision to innovate outside established boundaries. Because the Speed King was never just a title for a car.
It was a statement.
A declaration that performance excellence is not reserved for legacy empires. That bold engineering can emerge from unexpected places. That speed, at its highest form, is a universal language spoken through precision, courage, and vision. And as headlines spread, as debates ignite across forums and boardrooms, one thing becomes undeniable. The landscape has shifted. Competitors recalibrate. Investors reconsider. Young innovators feel something awaken.
Possibility.
The hypercar rests once more, silent, composed, almost modest in its presence. But its impact is anything but quiet. Because somewhere, another engineer is now asking a dangerous question. If this is possible, what's next? And that question, more than any speed figure, is what truly changes the world. The horizon remains infinite. The pursuit never ends.